motion in a straight line. Exercise questions. So we have the first question. Which of the following examples of motion can the body be considered approximately a point object? So here our concept is if the size of the object is very small compared to the path traveled by the object, then it can be considered as a point object. For example, the case a railway carriage carrying without jugs between two stations. So you can assume that the stations are far apart compared to the length of the track traveled by the body. The size of the train is small, so can be considered as a point object. The same we can argue for case B also. So we can take as a point object. Other two cases are that much not convincing. So we consider A and B as the answers. Now, question 2. Position time graph is given. Now, various options are there. A or B lives closer to the school. Okay. So here we can see A is having home at B, B is having home at Q. Therefore, you can say the distance traveled along exact y-axis. You can see the distance traveled. So to B. Therefore, we can say A is close to the school. So the answer is A. A lives close to the school than B. Now part B, A or B, who starts earlier from the school. Again, time axis you can see. A starts at 0 time itself, but B started later. So again, answer is A. Next, A or B walks faster. You know, slope of position diagram gives speed of the object. Here, slope of graph B is more. So we can conclude B is faster. Then part D, A and B reach home at the same time or different time. So reach home. As per the graph, they reach home at a different time. If the graph is in the same straight line like this, okay, I think that is the answer given to the book. So in this way, and this graph meets this straight line, then we can say they reach at the same time. But here, there is a print problem, I think. So according to the graph, they reach at a different time. Then part E, A or B overtakes B or A on the road once or twice. You can see there they meet only one time at this particular time. This particular time they meet. So only once we can see the overtake. So that is question 2. Come to question 3. Woman starts from her home at 9 a.m. walks at a speed of 5 km per hour, and the office is 2.5 km away. That means what's the time taken by her? So time is equal to, we can use the formula, this time is equal to distance divided by speed. So you get the answer around 0.5 hour, means around 30 minutes, which means she reaches the office at 9:30. She reaches the office. Then she remains there in the office, and at 5 o'clock, you can see she returns back with the speed 25 km per hour. So that again we can calculate the time. So that time you will get around 5 minutes she takes, again we can use the same formula, she takes around 5 minutes to return back to home. So now we are asked to draw a graph. Okay. So here, so assume that she starts at 9 o'clock, and this is 2.5 kilometer, 2.5 kilometer distance. Scale and all, you have to choose suitable scale. Okay. Now what happens? She starts with the uniform motion. So you can see here at 9:30. 9:30, she reaches office, and in the office she remains till 5 o'clock. We can adjust the graph with the kink here. Mathematics method you have studied. Okay, so till 5 o'clock she is in the office. Then next 5 minutes she returns to home. Okay, so that this is 5 hours and 5 minutes. She returns back to office. So if you back to home, so you will get the graph like that. Now again, next. Question 4. A drunkard walking in a narrow lane takes 5 steps forward and 3 steps backward. Every time he takes 5 steps forward and 3 steps backward. Now, each step is 1 meter long and it takes time 1 second. Now plot the xt graph of the motion, determine graphically or otherwise. And otherwise, how long the drunkard takes to fall in the pit 13 meter away from the starting point. Okay. So here we can say he takes 5 steps. 1, 2, 3, 4, 5. Each step is 1 meter and takes 1 second. Then what happens? He returns back 3 steps. That also 1 meter and it takes 1 second. So effectively you can see he completed 8 seconds now and his displacement is only 2 meter. So we can assume like this. In 8 seconds, the person travels only 2 meters. Now by trial and error we can calculate. So what happens? In 16 seconds, 4 meter. Then in 32 seconds, 8 meter. After traveling 8 meter, what he is going to do? Next step, he is going to travel 5 steps forward. That means he is going to travel 8 plus 5 meter forward. Why then for this 5 meter, he will take 5 more seconds. So total time is 37 seconds now. Now 8 plus 5, total you will get 13 meter. And that point, the so-called pit is there. So he will fall there and afterwards he is not going to return back. That means how much time he takes fall in the pit. It took 37 seconds to fall in the pit. Now, if you draw an xt graph there, you can see the graph like this we can draw. time, position. So what happens initially? He travels 5 meter forward. So the graph will be like this. 5 meter he travels forward. Okay, so we can take this point 5, for which he takes 5 seconds. Then next what happens? He travels 3 meter backward. 3 meter backward, straight line, okay. 3 meter backward, so that this point is 8, and here position will be 2. This is 5. So like this, the graph will continue. Okay, so you can mark the graph, so it will be like this every time. In this way, the graph will go. So time increases while he travels forward, then backward, and again forward, then again backward. In that way, you will get the XT graph. Then next, question 5. A jet airplane traveling at a speed 500 km per hour. So velocity of the plane is given 500 km per hour. Velocity of the plane 500 km per hour. Ejects its products of combustion at a speed 1500 km per hour related to plane. Okay, combustion, exhaust gas. You can take a VGP, relative velocity. VGP is equal to 1500 kilometer per hour. What is the speed of the latter? Means what is the speed of the exhaust gas? That is what we need to calculate. Now we can have a VGP is equal to, so exhaust gas and the direction of the plane are in the opposite direction. So we can have relative velocity formula Vg plus Vp. From there you can calculate the value of Vg. Vg is equal to Vgp minus Vp. And substitute the value of Vgp and Vp, you will get the answer. Next, question 6. A car moving along a straight line highway with a speed 126 km per hour, that convert into meter per second, is brought to stop within a distance of 200 meters. So what are the quantities given? U is given 126 kilometer per hour converted to meter per second by multiplying 5 by 80. Final velocity V is 0. Then displacement S is 200 meter. 200 meter. Then what is the retardation? We can use the formula V square is equal to U square plus 2AS. Substitute the values and find the value of retardation A from the formula. And how long does it take for the car to stop? Once you get the value of A, use the formula V is equal to U plus AT. V is equal to U plus AT. And find the value of T. Direct question only you can calculate. Next, question 7. Two trains A and B of length 400 meter, which are moving on two parallel tracks with a uniform speed of 72 kilometer per hour. Both are in the same direction. So both are having same speed in the same direction. Therefore, we can say UAB, relative velocity of A, relative initial velocity of A with respect to B is UA minus UB, you know. So you will get 0. Their relative velocity is 0, as they are in the same direction with the same speed. Then driver B decides to overtake A and accelerates 1 meter per second square. So this acceleration is the relative acceleration of B with respect to A. So you can take as relative acceleration, because relative acceleration will be 1 because A has no acceleration at all. So B has acceleration 1. So relative acceleration is 1 meter per second square. After 50 seconds time, after 50 seconds, the guard of B just brushes past the driver of A. What was the original distance between them? Okay. So we can use this formula S is equal to ut plus half at square. But this formula you have to remember that this formula is in terms of relative values. S is relative distance, U is relative initial velocity, and A is relative acceleration. We write the formula directly in terms of relative motion. So from that you can calculate the value of S. Then next question. On a two-lane road, car A is traveling with a speed 36 km per hour. Okay, convert into meter per second. Then around 10 meter per second, you will get a VA. V velocity of A is equal to 10 meter per second. Then two cars, B and C, other two cars, approach A in opposite directions with a speed 54 km per hour. So velocity of B is equal to velocity of C is equal to 54 km per hour, means it is around 15 meter per second. At certain instant, when the distance AB is equal to AC equal to 1 kilometer, B decides to overtake A before C does. What minimum acceleration is required for car B? That is the question. So situation we can draw in the form of a diagram. Let A travels in this direction and assume that B follows. Then C is traveling in the opposite direction. Now between A and B, the distance is 1 kilometer, which means 1000 meter. And between A and C also same distance, that is 1000 meter. Now what is the situation given in the question? There you can see B decides to overtake A before C does. Before C passes A, B has to overtake A, for which how much should be the acceleration? That is the question here. Okay. So how to calculate acceleration? So first of all, we can calculate the time taken by C to reach A. There you can see velocity of C with respect to A, relative velocity we need to calculate. So we have VCA because both A and C are in motion and they are moving in the opposite direction. So therefore it will be VC plus VA. So you will get 25 seconds. So then how much time C takes to reach A. C is moving with the uniform velocity. As C moves with the uniform velocity, then we can use the formula S is equal to UT. So S is how much? 1000. Substitute the values there. S is 1000. And U, when you take U, you have to take their relative velocity. Relative initial velocity 25 and time t. So find the value of t from this equation. You will get around 40 seconds is the answer. That means C takes 40 seconds to reach A. Before that, A has to overtake. So now we can calculate again using the formula S is equal to UT plus half AT square. Half AT square in the case of B and A. B and A. So you can substitute the values again. Relative distance between B and A is 1000 meter. Their relative velocity, they are traveling in the same direction. Therefore, the velocity of B with respect to A, you have VB minus VA because they are traveling in the opposite direction. So you will get the answer around 5. So here value of U you have to substitute 5. And just before C reaches A, so you can substitute time t there. Then find the value of acceleration. So you will get the required acceleration. Okay, substitute S1000 relative distance, U5 relative velocity between B and A. Then what relative acceleration is required? You will get the answer just before overtaking uh, this 40 seconds. Remember, we are calculating minimum acceleration. Okay, so you may be thinking if it is exactly at 40 seconds, both will reach at the same time. But we are calculating minimum. Okay, what minimum acceleration is required. Next, question 9. Two towns A and B connected with the regular bus service and time period of the buses t minutes. That means after every t minutes. So if you are standing stationary in the roadside, you can see after every t minutes one bus is passing through that point. Then a man cycling with a speed 20 km per hour. This is the velocity of the cyclist. In the direction A to B, notices that a bus goes past him every 18 minutes. Every 18 minutes. Means after every 18 minutes, one bus will overtake him in the direction of his motion. And every 6 minutes, he could find a bus traveling in the opposite direction every 6 minutes. Then what is the period t and what is the speed of the bus? And buses are traveling with the uniform velocity or constant speed, we can say. Okay, let's solve it. Here, first one we can see the distance traveled by the bus between two successive overtaking of the cyclist. So D is equal. Okay. When bus travels in the direction of the cyclist, both are traveling in the same direction. So as both are in motion, we need to take relative velocity. Relative velocity of the bus with respect to cyclist. As both are in the same direction, then VC, VB minus VC into time taken. Time taken after every 18 minutes. So I will write 18 by 60 hours because the velocity is given in kilometer per hour. So this is the distance traveled by the bus between two successive overtaking of the cyclist. Okay. Now again, we can calculate distance traveled by the bus in the opposite direction between two successive overtake. So how much it will be? That will be VB plus VC, because the bus is traveling, bus and cyclist are traveling in the opposite direction. Relative velocity we need to add into 6 by 60 into 6 by 60, because after every 6 minutes one bus goes past the cyclist. Now see these two equations carefully. The buses are traveling in the opposite direction with the same speed, with the same time interval. So in such a situation, both are the distance traveled by the bus between two successive events. So in such a situation, you can see here, if you take 2 points, and the cyclist is at the first point, one bus will overtake him. When the cyclist reaches the second point, you can see next bus will overtake him. So the second bus will take this much distance from the first bus to overtake the cyclist with the constant speed. That's the first formula we have calculated. So the distance traveled by a bus from the first overtaking to the next overtaking. The bus is traveling with the same speed in the opposite direction with the same time interval t. So in such a situation, we can see between two successive overtaking, if the bus is having constant speed and every t minutes one bus is there, such a situation, you can see there the bus traveling opposite direction also should travel the same distance, because both the direction bus is going with the same speed. So in such a situation, these two d values are equal, because in both the directions, two reasons, please understand clearly, both the direction bus are going with the same speed, and in both the direction time interval of bus is capital T minutes. So in such a situation, both the direction distance traveled by the bus will be same. Okay, so we can equate these two quantities and can simplify and find the value of v. Velocity of the bus can be calculated. Now next, for calculating the time period, we consider the bus traveling in the direction of the cyclist. Between two buses, here between two buses, time interval is t. Therefore, the distance traveled by the bus during the time interval, distance is equal to distance traveled by the bus during the time interval is equal to Vb into t, speed of the bus into time taken between two successive overtakes. Then, if the first bus overtakes the cyclist at the initial point A, next bus overtakes the next point B, then T is the time interval. That means bus takes time interval T to travel from A to B. By then, between two successive overtaking, first overtaking at A, next bus overtakes the cyclist at B, by then cyclist also will travel the same distance. So what is the distance traveled by the cyclist by this time? That will be velocity of the cyclist into time taken by the cyclist. How much is the time taken by the cyclist between two successive overtaking? Time is 18 by 60. So distance traveled by the bus between two overtaking points is equal to speed of the bus into the time interval between two buses. And between two successive overtaking, the cyclist also will travel between those 2 points. Distance traveled by cyclist is equal to speed of the cyclist into time. So you can substitute the value of VB here and you can find the value of T. That's the question 9. Next, question 10. A player throws a ball upward with an initial speed of 29 meter per second. So take it as U, 29 meter per second. What is the direction of acceleration during the upward motion of the ball? You know, always acceleration due to gravity is downward. So acceleration is acting downward. Acceleration is downward. Then what are the velocity and acceleration of the ball at the highest point of its motion? At the highest point, velocity is 0. It is momentarily at rest. Still gravitational force is acting, so acceleration will be g, 9.8 meter per second square. Then next, choose x equal to 0 meter and t equal to 0 seconds to be the location and time of the ball at its highest point. We're asked to take x equal to 0 and t equal to 0 at the highest point. Vertically downward direction to be the positive direction of x-axis. So it is not a conventional way. Downward direction is taken as positive axis. Downward direction, positive axis. So this is positive x. Downward direction, positive x. Then positive x-axis. And give the sign of position, velocity, and acceleration during upward and downward motion. Okay. So first, this point is taken as 0, and that's the highest point, and time t is also equal to 0. That means clearly you have to understand that the ball is thrown from here, reaches the highest point, then falls back. So now you see there, wherever you calculate the position, you can see position can be here, 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 like that. And if you take this one as positive axis and this point is 0, that means position is always either positive or 0. Therefore, we can say position x is either greater than or equal to 0. Remember, downward axis is taken as positive axis in the question. That you have to see very clearly. Now, next, velocity we have to see. Velocity direction, when you see, this is negative x-axis. During upward motion, what happens? During upward motion, the velocity is towards negative axis. and at the highest point velocity is 0. Therefore, we can say upward motion. In upward motion, velocity is less than or equal to 0, which means it can be 0 or towards negative direction. Towards negative direction means negative value means less than 0. And during downward motion, we think about downward motion, highest point velocity is 0. Remaining part velocity is along positive axis. Therefore, we can say velocity is greater than or equal to 0. Now, acceleration. Acceleration is always acting downward. Downward means in this question it is along positive x-axis. Therefore, acceleration is greater than 0. Now come to the fourth part of the question. To what height does the ball rise and after how long does the ball return to the player's hands? To what height it rises? You can use the formula V square is equal to U square minus 2gh. Motion upward, g you have to take negative. No need to think about part C and all, that's a special case. This part D we need to consider only the normal situation. So final velocity V is 0, U is given in the question 29.4, so that height h you can calculate. Then time, use the formula V is equal to U minus gt. So again V is 0, you can calculate the time, but that time will be the time taken for the ball to reach the highest point. The question is that to return the player's hand. So whatever t you got in this equation, so find the value of t. Then the time taken to return back to the player's hand will be 2, because whatever time taken for the ball to reach the maximum height, it takes the same time to return back. So total time you have to calculate. Question 11. Read the statement and state whether true or false. With zero speed at an instant may have non-zero acceleration. It is true. Example, we can see a ball thrown at the highest point. Speed is 0, but non-zero acceleration. Acceleration is g. Part B, with zero speed may have zero velocity. Zero speed means object is at rest only. It is not at all in motion. Non-zero velocity is not possible, so it is false. Then part C, with the constant speed must have zero acceleration. So speed is constant. So it is one-dimensional motion. Motion along straight line means you can see speed is equal to magnitude of velocity. So constant speed means there is no possibility of any change in direction and all. So speed constant means velocity is constant. So non-zero acceleration. So the statement is true because velocity is uniform in this case. Part D, if the positive value of acceleration must speeding up. If the value of acceleration is positive, the object should speed up. Okay. It depends on the fixation of frame of reference, the axis. You see there in the last question, part C, we have seen acceleration is always positive. But when you throw that ball upwards, what happens? Its speed decreases. But you see, value of acceleration we have taken positive, but its speed decreases, just opposite to this statement. So it depends on the axis, whether you have taken downward positive axis or you have taken upward positive axis, and it depends on the point where you fix the origin at x equal to 0, t equal to 0, etc. So we cannot say generally it is applicable. It depends on the axis. Therefore, the statement is taken as false. Then next question 12. A ball is dropped from a height 90 meter on a floor. At each collision with the floor, the ball loses 1/10 of its speed. Plot the speed time graph of its motion between time t equal to 0 to t equal to 12 seconds. Okay, first of all, the ball is dropped from 90-meter height. We can calculate the velocity with which the ball strikes the floor using the formula v square is equal to u square plus 2gh. U is 0, v you can calculate. You will get the value of v around 42 meter per second. Then with the velocity 42 meter per second, it hits the floor and it will lose 1/10 of its velocity. 1/10 of its velocity is lost. 1/10 means 10%. 10% of 42 is 4.2. So with what velocity now it goes upwards? V dash is equal to, what is V dash? V dash is the velocity with which the ball bounces upward. V dash is equal to 1/10 of velocity is lost. Therefore, you will have a 42 minus 1/10 of 42. So you will get it 37 or approximately 38. With the decimal points you can calculate exactly. I will just write with the approximate values 38 meter per second. Okay. Now here you can calculate the time taken by the ball to fall. You can use the formula v is equal to u plus at and calculate the time. You will get around 4.8 seconds it takes to fall. Then now it bounces with an initial velocity 38 meter per second. Again use the formula v square is equal to v dash square. Now for bouncing cases, initial velocity is this v dash square minus 2gh. V dash square minus 2gh. So that to what height it reaches you can calculate. Also, so you find the value of new height. Okay, I will call new height as h dash. You find the value of h dash now. Also, you calculate using the formula v is equal to u minus g dash. So that g dash you can calculate means time taken by the ball to reach the maximum height. Time taken by the ball to reach the maximum height, t dash. So where is the ball now? Now the ball is at the maximum height. Next, what happens? From this height h dash, the ball falls. So how much time it takes to reach the maximum height? The same time it takes to reach, returns back to ground. So it returns back to ground again plus time t dash. It returns back to ground. Then what is its velocity? Again you have to calculate velocity with which the ball strikes the ground. V double dash you can calculate. So like that continuously you have to calculate until you get the total time 12 seconds. Here you have time 4.8. Here you will calculate t dash. So 4.8 plus t dash. Then again another t dash will take for the ball to fall. So once again you have to calculate that time. So continue the calculation until you get total time 40 seconds. Sorry, 12 seconds I think. Okay, yes, 12 seconds. So how is the graph there? Velocity time graph. Velocity time graph. So initially we can see the situation, the velocity of the ball is 0. velocity of the ball is initially 0 at that height. Then it attains a velocity like this. It attains a velocity 42 meter per second during the time 4.8 seconds. During the time 4.8 seconds. Then next step what happens? 10% of its velocity is lost. So this point corresponding to that velocity 38. Then what happens? 10% is lost. Then the ball begins to move upwards. Okay. When it goes upward, its velocity decreases. So like this. At the highest point. So here, this point represents the highest point. Then velocity becomes 0. So this will be 4.8 plus t dash. Then next step what happened? Now the ball is at the highest point. Now the ball falls. With how much time it takes with the same time to reach the ground back with the same velocity. So that here time will be 4.8 plus 2 t dash, because the velocity with the time with which it goes, the time taken by the ball to reach the maximum height is equal to time taken by the ball to returns back. Now the ball is again on the floor. What happens? Here 10% of its velocity lost due to bounce. Now again what happens? From the ground it goes upward so that its velocity decreases like this, and until this total time for 12 seconds you have to calculate continuously. So, like this you will get the graph. Now question 13. Explain clearly with example magnitude of displacement over an interval of time and total length of the path covered by the particle over the same interval. So you can see magnitude of displacement is distance. Total path length is also distance. So in straight line motion, you can see magnitude of displacement and total length of the path will be equal. So far the object keeps the direction. Okay, don't take it is returning back and out. If the object returns back, it will be always displacement, magnitude of displacement will be less than uh, the length of the path. For example, here, suppose the object travels like this from A to B. So if the object travels from A to B, then magnitude of displacement is equal to distance. Suppose after reaching B, the object returns to C. Then what happens? Displacement is AC, while distance traveled is AB plus BC. So magnitude of displacement is less than distance traveled. So what are the options? Magnitude of displacement either equal to displacement or magnitude of displacement is equal to distance or less than distance. I repeat, magnitude of displacement is equal to distance or less than distance in straight line motion. Then next, the magnitude of average velocity and average speed. So here also you can see just like distance and displacement. The magnitude of average velocity can be equal to speed of the object, or it is less than the speed of the object, because average velocity is average velocity is displacement divided by time, and average speed is distance divided by time. So whatever we have seen in part A, that same is applicable for part B also. Okay, so they can be equal, or the magnitude of displacement is less than less than distance, or magnitude of average velocity is less than the speed of the object. Now, next question 14. It's an application of the previous concept we have seen. A man walks on a straight road from his home to market 2.5 kilometers away. So he travels from home to market 2.5 kilometers away. So home, market, away with a speed of 5 kilometers per hour. The speed is 5 kilometers per hour from home to market. Finding the market closed, he instantly turns and walks back home with a speed of 7.5 kilometers per hour. What is the magnitude of average velocity and average speed? You have to calculate average speed and average velocity. Three cases are given: 0 to 30 minutes, 0 to 50 minutes, and 0 to 40 minutes. Okay. Now, first case, we can calculate how much time it takes to reach the market. So, how to calculate that? Time is equal to distance 2.5 kilometer divided by 5. So, we take a 0.5 hour means 30 minutes to reach the market. So take our first case. First case 0 to 30 minutes. That means he travels from home to market. When he travels from home to market, it is just a straight line motion. As it is just a straight line motion, okay. Average velocity, V average, is already given. He is traveling with a 5 kilometers per hour. 5 kilometers per hour. And in the straight line motion, the last question I mentioned, if it is only along straight line, then average velocity and average speed both are equal. Therefore, average speed is also, we have the same value. Average speed is equal to say 5 kilometers per hour. So distance and displacement are equal in this case. Next, what's the time taken by him to returns back? That also we need to calculate. His speed is 7.5 kilometers per hour, and 2 point distance is same. Okay, so the time taken to return back. So first part is over. Time taken to return back t is equal to 2.5 divided by 7 point. You can simplify so that you will get it around 20 minutes. Now try to give the answer for part 2. Part 2 answer. 0 to 50 minutes. 0 to 50 minutes means you can see he returns back to the initial position. Therefore, his average displacement is 0 and average velocity is also 0. Average velocity is 0, average displacement is 0. And how much is the average speed? Average speed is equal to total distance divided by total time taken. Total distance is 5 kilometer and total time it took 50 minutes. So 50 by 60 hour. Simplify, you will get the answer. That is answer to part 2. Now come to part 3. Part 3, 0 to 40 minutes. 0 to 40 minutes means he is traveling with the uniform speed. 0 to 40 minutes means he reaches this midpoint here, returns back. Okay, take a point A, the midpoint. As it is the midpoint, you know, this distance, AM distance is 1.25 kilometer. So first we can calculate average velocity. V average is equal to, what is his displacement now? He travels from home, reaches the market, returns back to A. That means now his displacement is HA, which is 1.25 kilometer. That is his displacement now. So 1.25 kilometer divided by, for which he took 40 minutes. So 40 by 60 hour. So simplify, you will get the answer. Now, next, average speed is equal. Average speed is total distance divided by total time. Total distance, he took 2.5 kilometer to reach market, then returns back to A, that means 1.25. The total 2.5 plus 1.25, that you will get 3.75 kilometer. 3.75 kilometer divided by 40 by 60 hours. Simplify, you will get that. Now, next, in exercise, okay, that's about previous exercise. We have carefully distinguished between average speed and the magnitude of average velocity. No such distinction is necessary when we consider the instantaneous speed and the magnitude of velocity. Instantaneous speed is always equal to the magnitude of instantaneous velocity. Why? So here, instantaneous speed and instantaneous velocity are considered. Okay, so here there is no time interval. We can say just like t tends to 0. So when t tends to 0 means at an instant you have to calculate what is the velocity and what is the speed. So when you go for a large time, then only you need to think about the average values. Now instantaneous values means whatever happens at an instant. So at one instant when you take there is nothing to distinguish the speed and velocity. Only the difference is that one is having direction and other one is not having direction. That's the only difference. So when the time interval turns to 0 at an instant, when you calculate, always the magnitude of velocity is equal to magnitude of velocity is equal to speed. Okay, so that is the reason. If there is no a large time interval, there is nothing to distinguish velocity and speed other than the aspect of direction. Then next question 16. Look at the graphs carefully and state with reasons which of these cannot possibly represent one-dimensional motion of the particle. Remember, it is one-dimensional motion of the particle. First graph is a position time graph. When you take this position time graph, you take a particular time, this particular time. When you take this particular time, corresponding two positions are there. So if the object travels only along straight line, okay, If it travels, then returns back, whatever the situation, at a particular time, it has only one position. Okay. If same position you can see here, but time will be different. If it take 10 seconds to reach here, then 3 more seconds to reach here, then time will be 30. Same position is there, but one for 13 second and one for 7 second, like that. Time will be different. Anyway, at what particular time, two positions are not possible if the particle is in straight line motion. Therefore, this graph is not applicable. What is the reason? It is not possible to have two positions at a single time for a particle in one-dimensional motion. Now, second case. Second case also, we can consider a particular time. So I have taken this particular time. See here, velocity is positive. At this point, velocity is negative. Is it possible to have positive velocity and negative velocity at the same time for a particle in one-dimensional motion? Not possible. The particle can travel in one of the directions. That's it. So therefore, this graph is not applicable. What is the reason? It is not possible to have two directions for a velocity for the velocity at a particular time. It is not possible to have two directions for the velocity of a particle in one-dimensional motion at a single value of time. Now, next, graph C. Graph C again. We can see there it's given speed negative value. So speed cannot be negative. So graph is not applicable. Next, graph between path length and time. Okay. You can see there the path length. Path length time increases here, you can see. Is it possible? So if you take this one origin 0, path length increases, then path length becomes 0. So here, just consider an object returns back to the initial position. We say as the object returns back to the initial position, its displacement is 0. But is it possible to say its path length becomes 0? Never. Path length always increases, even though the object returns back. Length of the path traveled by the object increases only. Only its displacement can be 0. But here the graph shows that the path length increases, then path length becomes 0. That's not possible. As the time increases, path length also increases. Length of the path traveled by the object always increases if the object is in motion. Therefore, this graph also not possible. What is the reason? The reason the path length cannot be decreased. Path length of a particle always increases. Now, next, question 17. XT graph is given, position time graph. Is it correct to say from the graph that the particle moves in a straight line for time t less than 0? That means this part t less than 0. Then afterwards in a parabolic path during the remaining time interval. It is not possible. So what is a graph? A graph represents the relation between two quantities. Shape of the graph is not the shape of the path traveled by the object. Position time graph, straight line means we know the particle is at rest. Okay. It does not show that particle is traveling along straight line. It gives an idea that particle is at rest. And afterwards it is a curve. Position time graph is curve. What is the meaning? And it is given for one-dimensional motion also. Position time graph is a curve in one-dimensional motion means the particle travels along a straight line with the non-uniform velocity. particle travels along the straight line with the non-uniform velocity. Path of the particle is straight line because one-dimensional motion. The graph is a curve because its velocity is non-uniform velocity. So therefore, graph represents always the relation between two quantities. Shape of the graph is not the shape of the path traveled by the object.